Yes.
This meeting is being recorded.
Got it. Yes, sir. Okay, so let's start. So today's our team will be focused on implementing this use case that we have in Azure, and particularly using all the data science tools and the machine learning tools that Azure has, right? We are going to do some data engineering on that. First, we are going to make a store where we keep our raw data. And then from there, we are going to move on to the usual transformations and data profiling, and then modeling and all those things, right? If possible, an inference pipeline also. So let's begin. Also, please free to ask any questions if you are having any doubts. So my beginning point was our Git repo that we have, and particularly the task for data pipeline, which has some data engineering activities, some modeling activities, and a lot of visualization. So we'll not focus on the visualization today, but mostly on how to implement this in a cloud-native machine learning environment like Azure. Okay. So we begin with the one of these. Any one of these will do. And here we have some transformations. Actually, I have it open. Here we have a bunch of transformations that discusses about the data, reads the data, shows the data frames, and finally goes on to do some engineering, some minor engineering like these things to make the modeling easier, right? To put less load on the compute that will be making the model, and then to make the feature engineering easier to capture better variance in the data. Right? So we do all these things basically to make our job easier for modeling, to make a better model, more leaner, faster model. Now, the thing is that these things are not just steps for visualization. Even for training and for inference purposes, we need all these steps, right? That is why these steps not only should be there in the notebook, it should also be there in a defined process, a process that is repeatable, and we can call it on any new data that we have in the future, right? All these activities like splitting data and all these come after we have dealt with these basic engineering activities, right? So these need to be part of some sort of pipeline that can be called again and again on new data, and then we can do all the splitting and modeling part, all the good things, right? So let's go on to any questions up to here. Anyone? Do we all agree that these engineering part needs to be part of some sort of repeatable pipeline?
Yeah, to make it reusable. Yes.
Yes, yes, to make it reusable, right? Especially these things. Okay, so that brings us to our environment, which is Azure. And I have worked on Azure for quite a while, but for a few years. And I have got to implement some wonderful things, just some basic things about Azure. For example, when you log in, you will see the screen like this, right? And here you will have some recently used utilities, plus some other major things that you might need in future, like resource group, subscriptions, anything like documentation, all these things. Okay. From here, the main thing will be subscriptions, where you need to have a subscription that is in a billing account because there is billing involved. And inside the subscription, you will find there is a spending rate forecast and all these things. Right? The important thing that you need is the resource groups. This resource group is the main kind of a namespace under which you will be keeping all the artifacts and models and data and whatever. So if I go into this resource group, I will see that I have some artifacts, right? And these artifacts are a very simple artifact. This is a storage artifact, something like an S3. In this case, it's like an Azure blob. This is the main Azure machine learning component. And then these are keys and so passwords and secrets that are kept to do all these activities in production, right? This one is the local Docker hub. So this one is our Azure ML Docker hub, Azure Container Registry. As you know, it's the public Docker hub may not be very safe for enterprise purposes. So always make sure to make your own container registry in which you will keep all these images, right? You might upload your own custom images here also, but the process as it is, we will see is that they automatically generate a container and then push it into the cloud. Right? So sometimes Azure will automatically do that. Sometimes you'll have to do yourself. So these things we can find out and talk about later. We will straight go into the machine learning studio. So if you go here and search machine learning, you'll see that there are some which you'll get Azure machine learning here. Right? There are a lot of other options, not important. Azure machine learning is the one that is important. If you go into Azure machine learning, you will find that you will have to create some sort of a namespace here also, kind of a top level group in which you will be doing things. So this is the machine learning workspace, the one that I have opened here actually. And in here, the first thing you will see is that you will have some networking and some overview stuff here. All the details of your machine learning subscription here. These are the details based on which you will be billed, right? So be careful to review all those in which region you want, what kind of a subscription and all those things. Notice this ML flow tracking URI, something which is very subtly put here, but is very, very useful. So all the things you do in Azure machine learning are having ML flow artifacts using which you can monitor and do a whole bunch of interesting things. But we will not go into there. We will go into the non-studio, right? The studio is the main place where all the machine learning and data science happens. Any questions so far, like regarding Azure or machine learning? Has any of you seen this before? I know Manasa has seen before.
Yes, right. Yeah.
What
I
about?
haven't. Is this all free?
No, no, this is not free. You know, it's kind of a
Um,
no. Yeah.
I
Yes.
think Classic Studio is free, Roy, but I think they were going to deprecate it soon. But I know it was getting deprecated in 2022, but I don't know which month it was getting deprecated. But other than that, we'll have to use ML Studio. The Classic Studio might go away soon. Classic Studio was actually free.
That not to do Classic Studio. Instead, you might do practice in Python and then move on directly to the current version of the studio. It is much better with a lot more stuff here,
True,
right?
true. Yeah, but people who are like was getting started, the Classic Studio was like handy and easy, like just go and drag and drop. But now
Technically,
we'll have to use.
if you are getting started, there is a $300 credit that will be enough to do some basic stuff. You can try out. So that's technically free. After that, if you really need to implement things by yourself, then you can get a subscription. Right? Also, you can see I do a whole bunch of stuff. It's not too expensive if you know what you're doing. See, the forecasted cost is $33, but it's happened before that it's 200 and then getting more and more. Right? So you have to know what components you're spinning up and all. But yes, $300 free credit will get you a lot of places. Okay, so here we come to the machine learning studio, right? The main place where all the activities goes on. For example, you have notebooks here where you can try out a lot of stuff. So I went here and tried out all the data engineering stuff that you have in this repo, right? All these things that is there in the repo, I went and tried in the notebook first. So once I saw that I was getting desired results and these are running nicely, Azure is able to do it in a good time and all that. So then I move on to, and by the way, to run this notebook, you need either your local VS Code, you can do that, or you need a compute instance. So I have a compute instance here ready. I'll show you how to spin that up, but you need a compute instance to actually run these codes. So just basically, I copied from here and pasted here. I did not do anything new. Yeah, these are the very same things that you're seeing there. Okay, the next thing that you will need is the actual data, right? So where do you keep the data? So here you can see that I have two pieces of data that is in the, one is in the file store and then the blob store. So this energy data is the raw data. So you can see that original raw data.txt. This is the file in which you'll see that it is in our repo also. Yeah, this is the file that is there. So you'll see original raw data.csv. This is the same file that is there. It is currently in version 2 because I had to change the schema and disable the ID. But other than that, it's the very same data, right? Inside here, you can either consume the data. They'll give you automatic codes to consume the data, or you can generate a profile and see how the data looks like. Right. I did generate a profile on version 1, but it seems it's been replaced. Anyway, so once you create the data here, so you can do create from local files. That's what I did. And if I go to kind of deploy a new version, if I go to new version, it'll immediately ask me the same things, which file you want to upload and all that. Okay. So using this, you can create the original raw data, and then comes the pipelines. Right. So the repeatable pipeline that I was talking about, you can see I tried a whole bunch of pipelines. Let's go to this one. So here you can see a job that has already run before, right? How will you know that the job has already run before? You will see that this is either green or red. If it is failed, it will be of some other color like red or blue or something. And if it is succeeded, you will see all the green stuff here. So it's check, 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 check. Right? These are like the kind of a wireframe of the activities that are going on. So you can get it in a list, and when you click there, you can directly go there. Suppose if this were a very long list, then it would be required, right? Here, let's see what I've done here. This one, as you know, is the raw data. So if I preview the data, I will see that it is just the data that I have there, right? All the raw data. And the first step that I run is an execute Python script, right? So inside this execute Python script, I actually have okay. Here is the script, right? So most of this is auto generated. I did not write any of this, right? All this is auto generated. So you will get a ready something to work with. And remember, it can have two data frames as input, data frame 1 and data frame 2. These correspond to these things, data set 1 and data set 2, right? Third one is something else entirely, but data set 1 and data set 2 you can get from anywhere. So you put in two data frames, try out you first try out with a few, like if you want to see the length of the data frame, and then I just took the steps from the notebook and copied them here. You can see these are the very same steps, right? I just took them from the Azure ML notebook. Let me launch another copy of here. So whatever was there in the notebook, I took these things, and these are in turn actually copied from here. I just filtered and used whatever were the useful ones. From here, I took them, I created all these attributes, dropped the ID if it is there. This reason was that in the original raw data set that I'm giving to Azure, I'm not giving the ID. So if I do a drop ID, it will give me an exception. But in future, if I'm getting new data in inference, then this will help me to drop the ID from there. Right? Okay. So these are more steps that I copied from those notebooks, and this is again another something I copied from Rich's notebook, which is KNN. So I took two of the notebooks, put in the best stuff, and then I dropped all these columns, right? And then just return that data frame. So this will just give us a repeatable pipeline where whenever we get new data, we can do this we can do these activities, right? Now, this does not have any imputation or anything, right? Just splits the data and create. This is the split data activity where you have like a 70-30 split, right? It's a randomized split. You can also do like other versions of split stratified and all those things, but I just did a randomized split. After splitting the data, I'm exporting to different buckets. So where am I exporting? I'm exporting to I'm exporting to the blob. I'm exporting to the blob, right? And if I go to the blob, if I go to the blob that is assigned, hey, containers, file shares, file store, omdem data, and you have xtrain and xtest here. Okay, so this is an 8 MB and this is 3.74 MB. This is the output of this repeatable pipeline. Okay, so this one exports to train and this one exports to test, right? This is one part of the pipeline. Did you understand any of this?
Yes, Roy.
Does this look good, Mac?
Yeah.
Mac and
Yeah, it looks
Paul.
good.
Looks good, right?
Yep.
So this part you can always do with any of the incoming data. You can just take off the split and create a way to export the data. Okay, once I have exported the data, I'm going to read this training data that I have exported here, and then start off with the next phase of the process. That training data is the energy process. So if I go to energy process data and I click on explore, I will see that I have a whole bunch of the required columns. Okay, so I have Q1, Q2, Q3, Q4, and all those things. The reason you need to export is because if you do any data transformation, these Q1 and Q2 are derived columns that are coming from the where is that? I need to keep the job open somewhere. So these Q1, Q2, Q3, Q4, these columns are coming from the execute Python script, right? The problem is that these derived columns do not appear in any of the following steps if you are doing everything in one go. If you are doing everything in memory, right? These may not appear. So what I did was I exported the data, so this pipeline can run for any new data. And then I got to create this energy process. This energy process we are going to create for the next phase of the pipeline, which is the actual training. Right? In this training job, as you can see that this training job also is one of the successful jobs. We are creating a number of steps. See here you can go, you will find some like activities more than what we have done previously, right? And here we are beginning with the energy process data. So this one is the, with all the features and the basic pipeline already finished, this is the process data. This data we are taking in as input to the cliff values. What is cliff values? This is actually an outlier processing step where it uses the percentile mechanism as the upper threshold and applies a 99 percentile outlier detection and removal using these column names. So these are all the numerical columns here. Notice that I did not put the site UI because that is the target variable, right? So I just processed on the input numeric variables. You can preview the data as a result data set here. On the top, you can see some distributions for the numeric ones, right? Some outliers it has removed. Okay, the next step is to clean the missing data, right? With clean missing data, this also is applied on the numeric columns and again only on the input columns. We have not yet touched the Y column, the target column. Okay. So here we are using a missing value ratios different, and we are replacing with the most frequent. Remember in the data processing notebook, I think I saw somewhere that during the preparation they're using the most frequent imputer. Okay, here they're using the mean, but I saw somewhere they're using the most frequent. You can use any one of them, right? Any one will actually do. So there are options, mean, median, mode, all things are there. Generate missing indicator column. This is required in different other cases. We are not going to use that. We are not going to generate a new column indicating that it is missing. Okay. Okay. The next step is edit metadata. What did I do here? What I did was to just indicate that these columns are not just string columns. These are categorical columns. So I converted all the string columns to categorical, right? So they made them categorical. Otherwise, what will happen is you will not be able to get the like the dummies. What you do with get dummies, the categorical value you cannot convert to factors, right? So now when we have edited the metadata and converted them to categorical values, we can apply the convert to indicator values transformer. Remember, these are actually transformers that are applied in a sequence, right? Here we are saying that okay, take these categorical columns, convert them to factors and indicator variables. Also, you need to override the existing categorical columns. If you need to keep them, that's fine. But in this case, after transforming to factors, I decided to replace them. So I made this as 2. Are you following me? Are you guys following?
Roy, can we see the result data set after the convert to indicator values?
Sure, sure.
Yeah.
Yeah, good question. Let me, I have to see that multiple times also. Okay, see. You have, where did they go? Yes, year factor 1, year factor 2, year factor 5, state factor, state 1, state factor, state 11.
Yeah.
Right? The commercial, residential, multifamily, commercial, education, all these things. These are automatic, right? Public safety type, retail, warehouse. So these are automatic. Yes, that's a good question. You should be able to verify that what you want is required. This option is something totally different. We will not use this in our case. So the next step is to scale the data. Remember that we were first doing imputation, then we were doing scaling of the numericals, then we were doing one-hot encoding, and finally clubbing them together before getting out the main training data frame. Right? These are training data frames. This is exactly what we are doing here. We are doing some outlier values. We are cleaning. This is imputation. This is converting to categorical values. This is the one-hot encoding step. This is the standard scalar step, right? So what do we do here? We use the Z-score mechanism. There are also other transformation methods. We use the Z-score mechanism on only the input columns, numerical columns, and then we basically feed that to another transformation. So if you see the transform data set, we will see that these are all Z-score transformed. Right? All the numerical columns are Z-score transformed. You can even see some bit of the distributions on top of them. They are somewhat normalish. Yeah. Okay. So next step is to, you see there is a step that converts the target variable to a logarithm, right? I saw it somewhere here, maybe. Yeah, somewhere here I saw it. So this is the step that actually applies the logarithm operation on the target variable. Right? So there is a logarithmic transformation which is done in place, which means it will replace the previous version of the column. There is non-logarithmic. Right? Here you can do other transformations also. And remember during inference time, we will have to bypass this step. Right? We'll take the transformation from here and then use that transformation on the inference. Okay, so we now got all our data ready. We now split the training data into test and into train and validation. So here we are doing a 0-point fraction of the split. We can even do like 70-20 or whatever. I use the default values. After splitting the data, you will get 2 data frames. One is the first split, and then is the validation split, right? Train split and validation. The train split you can feed to a train model activity, right? And here the label column will of course be the logarithmically transformed site UI, right? We are not generating model explanations for our first iteration. What model are we using? We are using the boosted decision tree model. This is actually an XGB model. If you check out the baseline model, yes, I followed this one. Baseline model. Baseline model notebook, you'll see that here we have tried the XGB regressor, right? So XGB regressor has these parameters, right? So these parameters are the same ones that we have here. So you have number of leaves, depth, and learning rate, and number of trees constructed. And after this model is trained on the training data, that data is fed then into a score model activity. The score model takes data from the validation data set and then the trained model, and then it will do the score calculation. Let's see what the output is of this. If there is any score data set, and the score data set will look like the input ones and then with the label, right? So you see these are all the input ones and these are the scored levels, right? So score levels is also somewhat normalish. And this is actually the log of the output energy user index, the intensity that we need. So if we need to report to the user, we will need to do an anti-log of this, and e to the power x of this, right? Anyway. Okay, so after we have scored the model, we are doing evaluation of the model. In this evaluation, it will show what is the evaluation metrics. So for example, if I view the evaluation results, it will show, okay, this is the mean absolute error, which is 0.44, root mean square error, 0.72, relative square and relative absolute. The thing that I observed is that this is almost equal to what we have here, right? So mean absolute error is 0.5, and root mean square is around 0.84, right? All these things we have here. See 0.44 mean absolute error, right? So this is pretty similar to here. In fact, these are the very same algorithms and the very same metrics that you can apply that we do in the notebook. After this is run and this is success, any questions on the training pipeline?
No, I think good, but yeah, like if probably broader audience might have more questions.
Okay. So, so once the training is complete and you have got the success message, you can create an inference pipeline. In the inference pipeline, you will see that there are two kinds of inferences, real-time and batch. And this is a thing about machine learning, that there's always real-time inference use cases and there are use cases where you will do batch inferences, right? So here, since this is not a live system, we are going to do batch inference. If you click on batch inference, what you are going to get is where was that? Pipeline. Uh, Designer, yes. If you do a inference pipeline, click that button, what you're going to get is something like this. So I clicked on the real-time pipeline just for example, and I got this one. So this is a web service input. You can call this whole activity and model and data transformation pipeline using a REST API. And these are all the pieces that the Azure ML automatically includes in your inference pipeline. So this is the raw data. These are the transformation steps. So this activity will do the cleaning values, right? This will convert it to the indicator values. This one will do the standard scaling. And finally, this one has to be removed actually. But anyway, so this one will do the scoring. And finally, you will get the output from the web service output. Right? So if you go to say endpoints, I have not deployed an endpoint. This is where I need the team's help in doing. But the main motive is that we have to create this inference pipeline properly and then deploy it as a artifact. When we deploy it, we should be able to give new batch files, new input, and get the inferences like this. Right? So then this is an entirely cloud native, production friendly. Most importantly, you can put this in production right away, right? And then there's very little coding going on. This is mostly a low code scenario. You can do coding by going to the notebooks and all, but this is mostly a low code scenario where you're training the entire pipeline, doing data engineering, and then able to do inference just like that, right? Here you can see there are a lot of components that you can use to model score. For example, cross validation, and if you have some image processing models, you can do different kinds of clustering, PyTorch, hyperparameter tuning. There can be n number of things that can be done using this.
Yeah, because everything is like already being pre-coded as a model, right, Roy? Yeah, it's pre-coded as a model. But in case if we want to have a like our own design specific, then we can actually like override that and do
Yes.
I mean like customized coding for that particular
Yes.
model.
So if I click on Python language, where is it? Why is it escaping? It says two things: create Python model and execute Python script. Right? Execute Python script is the one we used in the repeatable pipeline. But this create Python model is very interesting. If I click here, it already has the code where you can create your own custom model and produce a predict routine where you can score the levels. So internally, we know that this is what is going on, right? So this is the part of the inference pipeline. So I need the team's help in basically completing this, okay, and then trying to get it deployed. So our deployment is like very easy, right? You just click on deploy, submit here, you deploy, that's done. Azure will do everything for you. But yes, this is where I need some team contribution in, right? Uh, that's it. That's all I have for today.
You said you need team contribution here?
Yes, yes. Maybe some help in creating the proper inference pipeline, and then calling this service from outside to verify that our service is working. I can do it myself, but it will take some time. But yeah.
Yeah, I'll just take a look at that as well, Roy. Yeah. The deployment part, I'll take a look at it.
What does the web service do?
Pardon?
I don't understand what the web service is. What does that mean?
Oh, web service is where you call, what is a web service? Web service is basically how to use a web service input, right? Where is that? Create a pipeline, the cluster. Got it. Let's go to the notebook. Sample tutorial. Deploy. Okay, deploy to, let's say, cloud. Okay, web service will be something you can call by using REST API, right? Something. What is this? You should not have consuming the model code. Okay, let me show you from my other subscription. This one does not have that. So this one has like a trained model inside it, and the web service looks like pretty much. If I go to endpoints,
It will be more like a URL where you can access your model.
so this is the REST endpoint, right? See, the REST API, if you call this API and pass whatever you need to pass, you will basically see if you test, right? Or if you consume rather. If I go to Python, see, this is how you consume the service. You produce the URL, right? You give in all the input parameters. This is a house price regression project. So you give in all the inputs as a JSON. You give it a URL, right? And you give a primary key. So this is for authentication. And then once you package that up in a JSON header, you can just call request. Okay, you'll get a response. So it's request response.
Oh,
does
okay.
that make it clear? So that's how you use models. So after you have done the modeling, what you are going to do is you are going to get some new data, okay, for which you need some sort of answer, prediction. You are going to pack it up in a dictionary, use the model URL that you have, use the authentication key, and then inside pack it up in a Postman. You can even do this from Postman. So pack it up as a header and just put a request to that URL. This is also available from Postman.
Okay, that sounds great.
That's how you use models, right? Similarly, you can take this inference pipeline, and after it does the inference, you can call the inference pipeline from a REST API, and then you will get an answer, like a prediction. That's what this model, the whole thing is for. Yeah. So what do you guys think?
That really looks nice, Roy.
Yeah,
Nice.
that's great.
I want to make this better.
Probably we can still fine tune them, but
Yeah.
but for now, like we can just try to deploy once and then fine tune and redeploy.
So how do we collaborate? Do I give you access into this so you can go and make some changes?
Probably like if you say like giving access, I'm not sure. Like probably you'll have to add us in your account, or I'm not sure. But yeah.
Yeah, that I can do. All the subscription thing.
Yeah, subscription thing. Yeah, probably we'll have access only to. Yeah, depends.
Yeah. Anybody who wants to, so this will be temporary. I will delete all these things later on.
Okay.
Maybe for about a month, I will keep these things up so people can go in and check out, right?
Sure, Roy. You can add me. Like I can just give you my details. Yeah, and we can collaborate on this.
Yes. I think those things you are more comfortable with access and all that. I don't do admin stuff at all, right?
Yeah. Even I'll have to figure out. I'm still like working on my admin part of the Azure, but yeah.
Oh, then let's do that together. Let's work out how to give access to people so that they can, for the time being, go in and play and have some fun, right?
Yeah.
Don't worry about the cost. I will bear it. It's on me. But just play around and have some first-hand experience of cloud tools and Azure machine learning, right?
Right.
Awesome.
I think our meeting is ending in 1 minute, Troy.
Hey, is the screen shared?
Yes. I think you were sharing, right? Did you stop sharing? I think you stopped sharing.
When did I stop sharing?
Just now.
Oh, okay. I see. Okay.
Yeah. The meeting will end in 1 minute. Should we rejoin Roy, or we are good?
No, I think that's enough for today. You can share our feedback, your feedback with the team on Slack, and also promote these things to others, right?
Yeah. We can do that, and I can put on the. I think Komal can share the recording as well.
Sometime in this week we can try and sit together and work out how to give access to people, right?
Sure, Roy. We can do that. Yeah, we'll set up a time and we'll do that.
Okay. Thank you, everyone.
Thank you.
Thanks, both of you.